Hi Pre-Calc. We're going to take a look at some graphing techniques here, kind of going over everything you've learned thus far, hoping to maybe separate the ideas in your brain a little bit and take a look at some harder problems. Okay, so the first thing we learned, when you see a negative out in front of the function, what that negative means is you have to reflect your graph over the x-axis. Okay, what would a value, okay, out in front of the function represent? Okay, so that is going to be our vertical stretch and shrink. For example, if you see a 2, you're going to stretch by 2. If you, for example, see 1/2, you are going to shrink all your vertical numbers in half. It's exactly what you'd expect. Okay, how about a negative inside the function? Negatives inside the function mean that you need to reflect over the y-axis. Okay, so take a look at the parentheses or the function and see where the negative is located. The b value there, that is going to be a horizontal. Okay, but horizontal is weird. Everything inside here is kind of the opposite of what you'd expect. Okay. So if you see a 2, you are going to do a horizontal shrink. Okay. And for example, if you see 1/2, you're going to do a stretch by 2. Well, that's weird. But it is X-Files. Everything inside here is weird. If you see a plus C, okay, a plus C, you are going to shift left and right. So this is horizontal shift. And just like horizontal stretch shrink, if you see a plus C, that means you go to the left. And if you see a minus C, you're going to go to the right. Okay? The number out here, this value right here, plus D, that is going to be your vertical shift. And all things vertical work as you'd expect. Okay? So a plus D would have you go up, and a minus D would have you go down. Okay, so vertical stretch and vertical shift work like you would expect. Okay. Okay, always make sure that your equation is in the correct form and that it is factored. Okay, in the correct form. Sometimes I would call this the ready form. Make sure your equation is ready. Okay, all right, so let's take a look at some very challenging graphs here. Is this equation ready? And the answer is no, it is not ready. Okay, because the 2 is next to the x, which means we're going to have to factor it out. Now, should I factor it out of the radical sign? No, we're still going to keep the 2 inside the radical, but then we're going to have parentheses x plus 4. Okay, I'm going to list my transformations in order. There's 1, 2, 3, 4 transformations, and the proper order would be to state them left to right. Okay, so a 3 outside. Remember, all things outside are vertical. So the 3 right there is going to be a vertical stretch by 3. You have to say vertical because there's also such things as horizontal. In fact, right there I see a 2, so that's going to be horizontal, except it's not a stretch. Everything inside is weird. A 2 means that you have to shrink in half. All right, a plus 4 means we're going to shift 4 units to the left, and then plus 2, we're going to shift 2 units up. Okay, so these are the transformations. I am going to go ahead and write down the basic growth chart for a square root. So the over numbers and the up numbers are 1, 1, 3, 1, 5, 1, 7, 1. Okay, but we have to adjust them. A vertical stretch by 3. Okay, the vertical numbers are up, so I'm going to multiply all those numbers by 3. The over numbers, the horizontal numbers, have to get shrunk in half. So So all these numbers, not 1, but 1/2. Not 3, but 3/2. Not 5, 5/2. 7/2. And I always like to kind of write the halves in terms of a mixed number. 3/2 is 1.5, which is going to be okay because a half and a half of a box, that's going to work out nice. 5/2 is 2.5. 7/2 is 3.5. Okay, something else I like to do just to make sure that I've got this thing going the right way, okay? Sometimes I'll do like a little doodle over here, or sometimes people like to draw a dotted one over here. So a regular square root goes up, up, up to the right. There's no reflection happening. My graph still has to be growing up, up to the right. Okay, but I have to move it. I have to go 4 left and 2 up, so my starting point is right there. 4 left, 2 up. Okay, got it, got it. The horizontal stretch shrink is going to be on this growth chart, and as long as I grow up, up, right, I'll have it. Okay, up 3, 1, 2, 3, over a half. Up 3, 1, 2, 3, over 1.5. A half of a box, and then 1. I'm going to go one more time. Up 3, over 2.5. 2.5 is right there at the tippy corner of the y. So here is the square root function. Okay, there is a way to check this. Maybe that point right there would be the nicest one. We have the point -2, 8. I'm going to take -2 and I'm going to plug it into the equation right here. 2 times -2 is -4, plus 8 is 4. Square root of 4 is 2, times 3 is 6, plus 2, that point works. Okay, you could always take your point and plug it into the original equation. Do not plug it into this equation. If you messed this equation up, everything's going to be messed up, and then you're going to check with the messed up, and it's going to seem like it's good, but it's not the correct one. Always check with the original. Okay, take a look at this one right here. Okay, sometimes people have a hard time graphing. I know this is a parabola, but guess what we're going to have to do? Lots and lots of factoring. Okay, so it is definitely a parabola because the power is 2. We've been doing that since the first chapter. The first thing I'm going to do maybe is factor out a negative. If it starts with a negative, take out a negative. All these numbers are also even, so I'm going to factor out a 2 from all 3 of them. This last term doesn't have an x, so that's the most you could take out of all 3 of them. Okay, you have to factor from everybody. So this will be x squared. This is going to be a positive 10x, and this one's going to be a positive 25. Okay, can this factor again? It certainly can. It certainly can because that's a perfect square trinomial. It's x plus 5 times x plus 5. But remember, everything in this chapter has been quantity squared. Okay, there's a special form that we call that, and this form right here allows me to see the transformations. Okay, so there's 1, 2, 3 things, and in the correct order, number 1, which axis would this be reflecting over? Yes, the x-axis. Step number 2. Okay, what does that 2 represent? That would be a vertical stretch by 2. And lastly, remember x-files, plus 5 means you're going to shift it left 5. Okay, I'm going to go ahead and draw the growth chart down for a parabola over 1 up 1, over 1 up 3, over 1 up 5, over 1 up 7. Same growth chart as the square root, except he grows up. The parabola grows up, square root grows to the side. Okay, any of the numbers have to get adjusted. The verticals have to get stretched by 2. So we're not going to go up 1, 3, 5. We're going to go up 2, 6, 10, and 14 if you want to write it down. Okay, how is this parabola going to look? Okay, a regular parabola looks like this. Reflecting it over the x-axis, it's going to be opening down. Okay, open down. Vertical stretch by 2. I have it right here in my growth chart. Angle left 5. Okay, I've got all all my transformations. I went left 5, vertical stretch is right there. I've reflected because I'm opening down, so I'm going to go over 1, and I'm going to go down 2, over 1, down 6. I think that's all that we can fit. Okay, when you draw your parabola, you go from this point to this point to this point. The next one is 10 units down. You are not allowed to touch -8 here until you're 10 units down. So when you go off the graph paper, don't touch him. Please also don't kind of swing back. The parabola is ever growing wider. He never grows skinnier once he grows wide. Okay, is there a point you can check? Yeah, all these points look good. You can pick any of them. And where would I recommend plugging it in? Into the original equation. If you messed up some of this factoring or something, your messed up point will actually work with your messed up equation. But none of this is correct. You have to check with the original one. All right, how else could this get a little more challenging? Of the fractions, of course. Okay, so I'm noticing that the x is not alone because there's a fraction by him. Okay, 1/4 is the same as divide by 4. So I know I'm going to have to factor that out, not out of the quantity cubed. -3, okay, I'm going to use big parentheses here. The 1/4 is inside. He has to stay inside, okay, but he has to get away from the x. I have to factor the 1/4 away from the x. But I also have to factor it away from the 3/4. Okay, 1/4 really means divide by 4. Okay, so x was getting divided by 4, but I took his divide by 4 away from him. I have to do that here. I have to take the -3/4. I have to take the divide by 4 part away from him. So all you have left with is -3. Wait, what happened? It's almost like I divided out his denominator. I factored out his denominator, which was a 4, and his denominator, which was a 4. I write 1/4 because it's in the denominator. You don't believe me? We can always multiply it back in to check. 1/4 times x works. 1/4 times -3. Let's see, 1/4 times -3. If you put -3 over 1, you multiply across the top, you multiply across the bottom. Okay, so that does work. So that's how you deal with fractions. You factor out their denominators. Okay, this equation is now in ready form, so I'm going to list the transformations in order. Number 1, reflect over the x-axis. Number 2, we've got a vertical stretch by 3. Number 3, I see a 1/4, but he's inside. Okay, everything inside is weird. I see a 1/4, so that's going to be horizontal. Is it stretch or shrink? It's going to be a stretch by 4. And lastly, we're going to shift 3 units to the right. Okay, I'm going to get the basic growth chart going here. So for a cubic, we go over 1, up 1, over 1, up. What's the growth chart for a cubic? 7, over 1, up, 19. Okay, we hardly ever need the 19 unless we're dividing. All right, so what are the transformations for this cubic? Vertically, I have to stretch you by 3. The verticals are the ups. Up and down is vertical. So I'm going to multiply these all by 3. Oh, I'm not going to need that for sure. Horizontally, I have to stretch by 4. All the overs get multiplied by 4. Okay, so I've got my vertical stretch and my horizontal stretch by the growth chart. Reflecting over the x-axis, I always like to draw little doodles just to make sure I draw the graph the right way. A regular cubic grows like this, up, 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 and away. Here's the regular cubic. So what does a reflected over the x-axis cubic look like? Anything above the axis would be going below the axis. Anything below would be going up. Okay, so this is what a negative x cubed would look like. But I thought that's what it looked like when you reflect him over the y-axis. And you're right, it's the same. Reflecting him over x or y, he comes out the same. Okay, so this is how I have to draw him. Okay, I have to make sure that I graph it with that direction. I have to make sure I go 3 to the right. 1, 2, 3, and that's where I'm going to start. Okay, down, down, right. All right, let's go over 4. 1, 2, 3, 4. And I'll go down 1, 2, 3. I'm going to go left 4 and then up 3. Okay, I don't think I can fit 21 on here. Over 4, down 21 is going to be way off the graph paper. Okay, so I'm going to go wide, 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 and maybe I'll aim for a point way down there. Okay, same thing over here. 1, 2, 3, 4 to the right, up 21. It's going to be way off my worksheet. So I'm going to make sure that I'm super, super wide and aiming for a point like that. Okay, let's make sure we did this correctly. Never take the vertex point, the center point. Take one that's way off the paper. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. I think 7 comma negative 3 is a point on the graph that I just drew. So let's check. 1/4 times 7. That would be 7 over 4. Minus 3 over 4 makes 4/4, which is 1. Cubed is 1. Times negative 3 is negative 3. It works. And I got to do some fun fractions. Okay, last challenging one. Writing the equation of the parabola, okay, with the transformations in order. Okay, so let's just write down everything that I see. I'm going to write down what I have to do. It says write the equation of a parabola, so that means they want y equals x squared. Okay, when it says reflect over the y-axis, I have to put a negative inside the function, inside the parentheses. Horizontally stretched by 2. Okay, horizontal has to go inside. Okay, and when it says stretched by 2, I'm going to have to put the number 1/2 because horizontal is weird. Horizontal translation, 3 units to the left, that's going to be x plus 3. Vertical translation, 5 units down, okay, that's going to be that's going to be minus 5. Okay, if he says down, you put a minus. He just does what he says. Okay, I think I'm ready. Y equals, okay, the quantity squared. All right, I've got the parabola. Check. Switch colors. Reflect over y-axis. Okay, that has to go inside. And a stretch by 2, negative 1/2. Okay, perfect. Inside. But remember, you have to write this in ready form. Okay, so we have to use double parentheses to make sure that we say x plus 3. Okay, we always get the equation in ready form. When we write it in ready form, so we're ready to graph it. And don't forget to say 5 units down. Okay, so this is the equation of the parabola. Okay, so let's go ahead and graph this. When you have a parabola, it goes over 1 up 1, over 1 up 3, over 1 up 5, over 1 up 7. Okay. We have to do a horizontal stretch by 2. Okay, and this is where some people get a little weird. It says stretch by 2, okay, but I write 1/2. What should I do here? Should I do the stretch by 2 or do the 1/2? Okay, if I showed you this equation, you would write these sentences. What does this 1/2 mean? It means horizontal stretch by 2. I have to make these horizontal numbers stretch by 2. Okay, so the table shows stretch by 2. My sentence or my transformation says stretch by 2. My graph will show a stretch by 2. The only thing that is written different is the equation. Okay. All right, so a regular parabola grows up reflecting it over the y-axis. Anything on the right goes to the left goes to the right, so he's going to look just like that. So it's almost like do nothing. Okay, check. Horizontal stretch by 2. I got it right here. Go 3 to the left and 5 units down. 1, 2, 3 to the left. 1, 2, 3, 4, 5 units down. Okay, so I've got the vertex. I'm going to grow up. I'm going to use this growth chart. Over 2, up 1. Over 2, up 3. Over 2, up 5. Can I fit 7? Over 2, up 7. 7 is, oh, it's one box off the graph paper. I'm going to put the point so I've got something to aim for. All right, so here we go. Nice wide parabola, okay? And why is the parabola coming out so wide? Okay, it's wide because we did a horizontal stretch by 2. Okay, a regular parabola widened, okay, should look wider than he usually does. Okay, that's kind of why some people like to do the dotted ones, over 1 up 1, over 1 up 3. They like to see the regular dotted shape so that they can tell, oh, mine definitely looks wider. Okay, and we can even take a point to check. I'm going to take this point. I always go for like positive ones. If I can, I always try to avoid these negative ones. 1, 2, 3, comma, 4. 3 plus 3 is 6. Half of 6 is 3. Negative 3, that is. Squared makes 9. Minus 5 makes a 4. I hope going through these challenging problems helps you solidify what to do with graphing. Thanks.